Welcome to episode 5 of the Norton Nemesis 1500cc V8 rebuild. And in this episode we're going to be finishing the strip of the engine, removing the wet liners, measuring up a few components, sorting out a few problems. After a good clean, the cylinder liners looked a lot worse than I first thought. There was quite a lot of rust damage and quite a lot of scoring. The liners seem firmly attached to the aluminium cylinder block. I'm thinking they should be wet liners and slide out nicely with some 2 rubber O-rings at the bottom, but I won't know until I try and get them out, or they could be just pressed in tight. Either way, we need to find out. Before I press the liners out of the block, I'm going to measure them with my internal bore gauge to confirm their size. They should be 73mm. Before I use my bore gauge, I'm going to very gently grip it in the vise on the little tang at the back to hold it secure while I set it to exactly 73mm. I set the micrometer to 73mm exactly, then offer it up to the gauge and gently move it backwards and forwards, up and down to get the highest reading possible, and then set the 0 on the dial. The bezel on the dial rotates to allow it to be lined up with 0. After a final check, we're ready to go, so now I mark each cylinder in turn with a pen to identify it so I can make a chart of sizes for reference. With all the bores identified, I can now use my internal bore gauge to measure the cylinder liners. The diameter should be 73mm, so I set the gauge to 73mm exactly. Any errors in bore size will show up as a positive reading past the 0. And this bore is plus 0.09, which is almost 4/1000ths of an inch, which is definitely not ideal. So now I'll make a note of the size and move on to the next cylinder to measure. I check all the cylinders at the top, in the middle and at the bottom, and it's amazing the range of sizes I'm getting, from almost 73mm exact, which is just perfect, up to 73.35mm, which is absolutely massively oversized. I can't work out why this is, because there's no lip where the piston rings don't travel. The liner seems to have barrel-mouthed. Another interesting thing is there's virtually no ovality in the liners. They're perfectly round. Well, out of the 8 liners I've measured, 2 of them I could probably use dimensionally, but they've still got this rust staining and scoring, and the rest are outsized by such a high amount that I can't use them at all, so I'm going to have to get new liners made or make some new liners. I don't want to rebore the liners because they're so thin already, and also I want to use the original pistons because they're virtually brand new. I pick up piston number 8 first. These are very short slipper pistons, so I measure the skirt near the bottom, and it's virtually to the right size it should be. It's barely anywhere at all. It only has very light scuffing, so these pistons are like virtually brand new, which is really hard to imagine considering them being up and down inside bores that are really worn or oversized from new. We don't know. I then check the remaining pistons, and I'm really surprised they're virtually all the same size, exactly 0.05 down from 73mm, which is not bad really, and the tops of the crowns are really clean and shiny. And up underneath the piston itself, it's absolutely like brand new. I keep saying this, but it's true. It's like brand new. I haven't even cleaned these parts, I just wiped them down with a bit of tissue. And the steel connection rods are very substantial, with very wide base to them. But I guess that makes them extra strong. The liner dimensions that I've measured have confirmed to me that they need to be replaced, so the next thing I need to do is get them out of the engine. So I'll machine up a little disc to go into the bottom of the cylinder liner so I can use my hydraulic press to press them out, because they're proper stuck in. The liners are very reluctant to come out and take quite a while, and the squeak's my old press. I've had it for 20 years and it's always done it. It's like an internal squeak. And finally the first liner comes out. It looks quite heavily corroded on the insides. There's quite a lot of corrosion and debris inside the engine in the water passages as well. Here I am hooking it out with a screwdriver. It's dry remnants of old oil seals, O-rings, bits of silicon cement. It all drops out onto the bench. I continue with the rough cleaning with the screwdriver, just getting out the worst bits, then I'm going to proceed to the next liner. The liner itself doesn't seem to clean up too bad. The rust is on the surface, it comes straight off with a wire brush. Even though these liners are virtually scrap and I won't be reusing them, I still need to give them a good clean up so I can pick the best one to use as a pattern to get the new ones made. And here's the first one, all cleaned up ready. I mark the liner from its original position, just in case. The second liner was just as hard as the first, and comes out covered in rust and debris and broken O-rings, and quite a bit of silicon sealer. And just like the first liner, the second liner's got bad corrosion behind it as well. With the first 4 liners removed, I can now turn the engine around and remove the other 4. This was a bad one. This one was really stuck and I had to twist it to get it out. It was just really difficult to pull out altogether. But eventually it came out. As you can see, it's quite corroded. After a long wait, Charlie Weaver was really impressed I got all the lines out with no damage to the engine. He had to have a tipple, or 2. With all the liners out, I can now assess the full extent of the corrosion to the block. There's no actual corrosion to the aluminium, it's just the rust from the liners that deposited itself onto the aluminium. So I started scraping it all off, but it's making so much dust and dirt, I thought this has got to be done in the garden. So I packed it all up and took it out in the garden. I'll also clean the liners outside as well. It's a nice sunny day today. As you can see, quite a lot of mess. Out in the garden, I can use my rotary wire brush. Well, it's not actually a wire brush, it's like a plastic abrasive brush. It's very soft, it doesn't damage the metal, but it removes all the mess. This is really good to use. You can really tell the spring's here because the sun's out and the bees are in the flowers getting all the nectar right next to my ear, buzzing away. All the mess and corrosion's coming off quite nicely. And I look up and the pigeon's on the bird table. He's waiting for Tracy to come out and feed him. He just sits there waiting. So now I can concentrate on the liners, removing all the rust from the outside. I use a metal scraper to remove the big bits, and then go over with my wire brush. This brings it up nice and shiny and clean. It takes quite a while. With the liners all cleaned, I now remove the copper rings from the top. These are like sealing rings, like a cylinder head gasket. There's one for each liner. And the best thing to do this is use my penknife The blade fits nicely between the copper ring and the actual steel part of the liner, and I can wiggle it in nice and gently without doing any damage, and gently pry it off. It's quite a tight fit, but then it needs to be. It did spring off a bit fast and I couldn't catch it, but that's okay. And here you can see the very thin spigot at the top. This is the reason I can't really give it a rebore, because there'll be no metal left. The next thing to do is give the cylinder block a good old jet wash. This will remove all the loose debris. So I first squirt it with some bike cleaner and give it a good squirt. It comes up really nice. I moved the block to the patio to let it dry off in the sun. It doesn't take very long, and here you can see it looks much better than it did before, with all the rust removed. You can clearly see the water passageways now, which are all clear. Back in the garage, I'm having a look at the alternator drive gear. This is a straight cut gear, but it's been ground on the side with what looks like an angle grinder to reduce its width for some reason. There was no alternator fitted to the engine. In fact, there was a blanking cover covering over the 3 holes and the mounting hole where it should be. So I went to the National Motorbike Museum and picked up the alternator off the spare engine and see if that fits, and it fitted straight on, but this one had a helical gear. And here you can see the helical gear's got some deep marks in it, like it's been running before. So when I tried it on the engine and married it up with the straight cut gear, it sort of fits and goes round, and the wear marks line up identically. This is really strange. I'm going to have to get a new gear made for the alternator that matches with the drive gear, but first of all I put the drive gear in my lathe and machine the teeth with a carbide tool to smooth them all off, because at the moment they're all rough. And as you can see, the sparks come flying off, because when you're cutting hard metal you get a few sparks, but that's quite cool. After a few minutes of machining, the gear's teeth are nice and smooth now, which is a lot better than they were before. And the gear is obviously slightly thinner, but it's still got plenty of meat on it. I think those teeth will be just perfect. With the gear machined, I then take some critical dimensions from the engine and produce a little drawing to take over to Steve at All Gears in Bracknell to produce me the new gear. I can now have a look at the actual main gearbox itself. This was really notchy to operate and really almost impossible to get neutral when you're actually on the bike. You could actually select through the gears, but it was so difficult. So I have a quick look, and it seems to be that the cam plate at the end isn't quite indexing correctly with the selector mechanism. So I try and get all the gears. You can actually select through the gears, but it's just so difficult and notchy and not very nice at all, and it should be really smooth and click freely. I continue changing through the gears to try and see what the problem is, and it turns out that the cam plate on the side by the selector mechanism isn't indexed exactly with the D-dent plunger on the selector drum. So one plunger was trying to pull it into gear, and the other one was pulling it slightly out of gear, and this was the problem. So what I had to do was some fine adjustments on the cam plate so that it engaged a tiny little bit earlier, and it worked just perfect. So then I could smooth it down with some nice smooth emery and make it really smooth, because it was actually quite a rough ground surface. So I kept rubbing it backwards and forwards with some 320 grit Abranet cloth until I get a nice smooth surface for it to run against. As I gently polished the cam plate down, I had to keep fitting it to the engine, check the operation, noting where it was rubbing, taking it off, filing it down a little bit more, but eventually I got the surface just right. After about half an hour of fettling, filing and polishing, the cam plate is actually working just right, so I can refit it to the lower crankcase to try the gearbox for the last time. With the cam plate fitted, I now remove the gear clusters from the crankcases and operate the mechanism with just the selector drum so I can see it click around nicely without any resistance from the sliding gears, and it does just perfect, so I'm really pleased with that. Here you can see it selects absolutely lovely, and I can get neutral easily both up and down the gears. So now the last final check, I put the gear clusters back in the engine and it turns lovely. I can get neutral, put it into first, back into neutral, nice and easily each time, so that's just perfect. So now I need to quickly modify the gear indent plunger to clear the spring. Following the marks I made earlier, I grinded away some material to clear the spring. There we go, that's much better. So now I can refit this to the crankcase, sliding it over the pivot point down into the selector drum, fit the washer and the split pin, and then reinsert the spring, and it should work just perfect now. With the new spring fitted, the gearbox works just perfect as it's intended. I can select all the gears, go up and down the gearbox through to neutral every time without any trouble, so that's really good. So now I can put this to one side while I concentrate on other systems on the engine, like the oil pump and the water pump. Well, thanks for watching. I hope you enjoyed it. And with the new liners and a new gear being made, I've now got a bit of time to do a lot of cleaning and evaluation of how systems work inside the engine. So I'll keep you updated, and I'll see you all soon. I've had quite a few comments about the ticking in the background on my videos. It comes from my 8-day wall clock in the lounge where I do my editing. I've got one in the garage and one in the dining room as well. We really like our wall clocks. They're so cool. They're very therapeutic and keep you calm and focused, especially when you're working on complex engines.